Okay, I'm going to give you a little background into probability, and kind of the goal is to get to understand what this means. I talked a little bit about that for the video for the lab, but I'll come back to that later in this video. So a probability is a number between 0 and 1, and that tells you the odds or probability of something happening. So I'm going to start with some simple examples and work up to this. So the roll of if you roll a die, a six-sided fair die, and get a 2, well, your probability of getting that 2, you measure it this way. It's the number of ways to roll a 2. There's only one way. It's got to come up 2. And the number of possible ways to roll a dice, or the number of possible outcomes. And you have 6 possibilities, 1, 2, 3, 4, 5, or 6. So the odds are the number of ways to roll a 2 by the number of possible outcomes. How about a 2 or a 5? So I'm going to roll, and I want to know my odds of getting either a 2 or a 5. Well, I add the probabilities for each. 1/6 for rolling a 2, and the probability of a 5 is 1/6, so I add them together, 2/6 or 1/3. In other words, if I roll a die, I'm going to have a 1 in 3 chance of getting a 2 or a 5. Now, another convention is that 0 is something that can't happen. And if I roll a 7, I can't do that. The probability is 0. Now, 1 is something that must happen. So there's only 6 possible dies, so what's the probability of rolling a 1, 2, 3, 4, 5, or 6? Well, it has to happen. It must happen. So that probability is a 1. But the mathematics shows it up. The probability of rolling a 1 is 1/6. The probability of rolling a 2 is 1/6, and so forth. If I add up all 6 of those 1/6, I get 1. Now that should always happen. Here's a little bit more complicated example. I roll 2 die and I add. So if I rolled 2 die, one was a 3, one was a 4, I'd get a 7. And there's 36 possible outcomes. You have 6 for each die and you multiply them. It's 36. So I've drawn a probability, I've drawn a sort of a map here that tells us what the odds of rolling a number are. And a little bit you want to interpret it correctly. So what I've done here is each of these heights are 136, 236, 336, up to 636 up here. Now, where do those numbers come from? Well, here's a chart giving all the possibilities. How many ways do I get a 2? Well, I got to have 1 on each die. There's only one way for that to happen. The number of possible ways to roll 2 die is 36, 1 over 36. Number of ways to get a 3, 1, 2, or 2, 1. 236. Well, there's 3 ways to get a 4. 5 ways to get a 5, 4 ways to get a 5, 5 ways to get a 6, so the odds of getting a 6 are 5 in 36, 6 ways to get a 7, so the odds are going to be 6 in 36, and so forth. Then it goes back down. The odds of getting a 5 and 8, 9 and 5, those are all the same. Okay, so this is my map, and you need to interpret this in a certain way. So this is the point that's on the graph. So that tells me that 8p of 8, the probability of rolling an 8 is 5 in 36. So this area is 5 in 36. This point right here, well, that's the probability of rolling a 2. That's going to be 1 over 36. So in other words, in this graph here, this point is an xy coordinate. X is 3, y is that. And so each of these areas represent the odds. So the odds of rolling a 7 are going to be 6 over 36. The odds of rolling a 6 are going to be 5 over 36. So since the height of these things is the odds, the width, the delta x is 1, well, that way I can represent the odds with an area of a rectangle. Does that make sense? So each of these rectangles represents the particular probability outlined here. This is called a bar graph, and this is called a discrete probability. And what we're going to interpret, if I look at the integral 2 to 3 of p of x, well, that's a probability that I'll roll greater than 2 but less than or equal to 3. Well, what's that probability? I can just look right here. For this area right here, 1 over 36. Well, what's the probability I roll? 2 to 7 tells me the probability I roll greater than 2 but less than or equal to 7. So that would be 3, 4, 5, or 6. Well, I add all these up. I add up these 4 rectangles, and I get 7 and 11 is 18. So I get 18 over 36, or 1/2. Okay. Now, what's my odds of rolling between a 1 and 12? That's going to be greater than 1, less than or equal to 12. Well, that has to be a 1, because that's all my possibilities. Does that make sense? So the idea is, because I can make this a function, I can think of integral with p of x as giving me a probability. Okay, and so that's one of the reasons why, anytime you start dealing with areas, you can start bringing in an integral. I hope that makes sense. So this is an integral for what's called a discrete probability. But the problems in the book have to do with continuous probabilities. And so you might have something like this. And if this is going to work, so what I'm imagining here is a die with infinitely many sides. And I get either 1 or a 12. So I don't have any ways to get a 1, so that's going to be my odds there. And so if I look for the odds between rolling a 7 and a 7.1, it's going to be this strip right here. And I'm just going to say, let's say the odds of rolling a 7 are still 1/6. The odds of rolling a 7.1 are going to be a little bit less. So what happens is I'm thinking of this area right here. So if I want to look at the integral 7 to 7.1 of p of x, well, that's going to be the odds of rolling 7 to 7.1. Well, I just look at this right here. This is going to be a good approximation. It's going to be 0.1 times 1/6, which is going to be 1 over 60. Okay. Now, if I go between 1 and 12, that's going to be the entire area here. So my odds of rolling between a 1 and a 12 are going to be 1. The odds rolling a 3 or a 3, well, this is where it gets a little weird. The odds of rolling a 3 to 3 are 0. So we can think of it this way, that's one way to think about it. I want to roll greater than 3, but less than or equal to 3. Well, that's not possible. Okay, so this would be the odds of rolling 1 to 12. Okay. Now, so the idea is that if what we do, the way I envision a probability is like this. I take a discrete probability where I have like 36 outcomes that I can count. 11 possible rolls. I have a bar graph. And then what I do is I imagine a situation where instead of having one die, I have infinitely many dies. And if I want to look at my probability getting between two numbers, 7 and 7.1, I kind of think of it as an area of a rectangle. So I connect it to the integral, and this magic function p of x will give me the probability of that. So it's kind of a weird thing. So, but the way to envision it is going from a discrete probability where your outcomes are choppy to a continuous probability where anything can happen. And so I think of it as an infinitely, as I think of this particular example as a die with infinitely many sides. I hope that makes some kind of sense. So just kind of want to review, and then I'll move on. So the idea is that a probability of an event is always between 0 and 1. So it includes 0 and it includes 1. 0 can't happen. 1, it must happen. Okay. Now if we have a probability distribution, that's what p of x is, and if I look at this integral right here, where t of o is the lowest possible event, t1 is the highest possible event, this integral has to be 1. Now, if I want to know that, if I say that, okay, well, t1 is the lowest possible, t0 is the lowest possible, t1 is the highest possible, I want to look at a to b, where a is greater than t0 but less than t1. This is going to be the probability the event is between a and b, and this integral will give it to us. And that's it. I hope that makes some sense.